Solving systems with substitution. We had these steps on Wednesday, so I need you with me now. First thing we do, remember it's 5 things. Make sure one equation is x equals or y equals. So one of them has to be either solved for x or solved for y. If it is, then replace one equation into the other. That's what you guys did on your warm-up. After you've done that, you know how to solve an equation, so that's what you do. You solve the equation. A system has 2 variables, so you have to plug back in and get the other variable. Last, write your answer as a point, which we also call an ordered pair. X, comma, y. Make sure I give you some time to do that. You get to substitute this expression, x plus 6. Where can you put that in the other equation? What is this equal to? Y. So where do you put it in the other equation? Y. This is a system. It works together. So I want to see you circle the expression and draw an arrow. So you know we're taking x plus 6 and we're plugging it in where y is. So we're going to take this top equation now, 3x plus 5y equals -10, and we're going to, instead of putting y, we're going to put x plus 6. So that way we can actually solve. So 3, what do I put instead of x? No, sorry, that's wrong. Backtrack. 3x plus 5. What do I put instead of y? X plus 6, because that's what y is equal to. It's like when I replace butter or oil with butter when I'm making brownies. Equals -10. Now that we have only x's, you can actually solve. So you're solving this equation just like you normally would. First thing you should do, distribute. And we're not distributing the 3x, so you can just bring it down. What's 5 times x? 5x. What's 5 times 6? 30 equals -10. Distribute. Now, combine like terms. You have 2 like terms right there. So you've got 8x plus 30 equals -10. Thirty's being added, so you would subtract. This is -10 down 30 more. So it's 8x is equal to -40. What's the last thing you need to do with that 8? Divide. So x equals -5. You can circle it. It's important. It's not your final answer. You got to plug back in to get y. Let's think critically right now. Which of these equations do you think is going to be easier to use to solve for y? Y equals x plus 6, the second one, because it's already solved for y. The first one, you could get the same answer, but it'd be more obnoxious. And I'm all about making my life easier, so let's use the second one. Y equals x plus 6, write it down. And now instead of putting x, you're going to replace We're going to replace x with -5. So it's -5 plus 6. So what is y equal to? 1. You have x is -5, y is 1, write it as a point, -5, comma 1. That's your final answer right there. Something is infinite solutions if you end up with, you solve the equation, And then you end up with something that is true, like 3 is equal to 3. Is that true? Yes. So you would say, you can say true if you want. This is, in fact, true, but your final answer is infinite solutions. Because we're talking about a system, that means that these two lines could be graphed to make lines that are overlapping. So make sure you write your final answer like that, infinite solutions. Something is no solutions if you end up with something that's false, like 2 is equal to 5. Is 2 equal to 5? No. You have a slash to the equal sign. If you want, you can say false, but your final answer is no solutions, which mean that you have lines that are parallel, that never cross. Is that you have to have an equation that's either solved for x or solved for y. Do you have an equation that's solved for x? No. Do you have an equation solved for y? Shoot! But you can get it. Which variable would be easiest to solve for right now? I would say x. Look at it. This x is almost alone. It doesn't have a variable in front of it. It's almost by itself. Not quite, though. You got to get it by itself. So you got to move the 6y. If you were to solve this top equation, it'd be a nightmare, and you get fractions. Don't do it. No. We're going to solve this bottom one for x. You have to do that before you start, so I'm going to how do we get rid of that 6y? It's plus 6y. You had minus 6y. So I'm going to draw like a squiggly line. So new, I'm going to rewrite my system now. Here's how we write this. This would be x equals, it would be 0 minus 6y. But you don't really need the 0. So it's just negative 6y. Let's go ahead and rewrite the top equation just for good measure. Negative 3x minus 18y equals negative 5. Now you have an equation that's solved for x. Now you can substitute. X equals negative 6y. So where can I put negative 6y in the other equation? If it's equal to x, where does it go in the other one? X. Right here. Draw an arrow. Show it to yourself that that's where it goes. I'm going to do this work over to the side. Negative 3, and instead of x, you're putting in parentheses negative 6y minus 18y equals negative 5. So the entire equation is staying the same, but you're not putting x, you're putting what x is equal to. Distribute. And you get positive 18y. Bring the 18y down. 18y minus 18y is 0. So you get 0 equals negative 5. Is 0 equal to negative 5? Heck no. Put a slash. Not true. You don't just say false and move on. You say no solutions. That's your final answer. So I need to see you subtract 2y. If you want to do it right below it, you can. If I subtract the 2y, I'm going to write my new system now. So this becomes x equals 2 minus 2y. These are not like terms. Please do not try and combine them. You have to leave them separate. The other equation is 3x plus 6y equals 6. You should be able to substitute now. Where can you put 2 minus 2y? On the x spot. Okay, I'll let you solve this one. Replace x with 2 minus 2y. Distribute. So you have 6 minus 6y plus 6y equals 6. The 6, negative 6y plus 6y adds to 0. So you are left with 6 is equal to 6. Is 6 equal to 6?
Yes.
That is true. So you say infinite solutions. If you were to graph this, you would have lines that were overlapping, which you could do.